Guys, so now we are going to work on SR and RS flip-flops with PLC. So this is our program window. Hope you all know about RS and SR flip-flop. So let's first see what is the working of RS and SR flip-flop. So this is the truth table of SR flip-flop. When both are 0, then the output is 0. When set is 0 and reset is 1, then the output is reset. When the set is 1 and reset is 0, output is set. And when both the output are 1, then output are 0. Okay? So it means in SR flip flop we get set only one time. Okay? When the condition are 1 0. Okay? In RS flip flop, for 0 0, output is 0. When the reset is 0 and set is 1, of course the output is 1. When the reset is 1 and set is 0, output is 0. But here there is a twist. When we on both the inputs R and S, at this time the output is also 1. So now we will see how this work on PLC. So this is our ladder diagram in SR flip flop. So this is simple as start bit. Okay, this is simple. Here I have give a stop name, but whatever input you have, you can give your name. Or now I will teach you how to change the names. See here there is a tab PLC tags. In PLC tabs you can click here on show all tags. In show all tag I0.0 is start. Here you can change as I am changing input 1. Okay, it is depend on you. This is LED. I am also using LED. At the time of stop you can take input 2. Okay, so this is for another RS flip flop that we will see later. Okay, so input 1, input 2, this is SR flip flop. I took it from here. Okay, so you can see here, if you go here in basic instruction, you have to open bit logic operation. In bit logic operation you will find SR and RS flip flop. Just you have to drag and drop here. Okay, so this is input 1, both are NO, and this is output. Just what we need to do, we have to download this program. Okay, so just download this code to device. Okay, load it. Okay, and start monitoring. Let's check here this is input 1 means I 0.0, this is input 2 means I 0.1. Okay, now as per the truth table, if both are 0, then the output is also 0. This is our Q 0.0, this is output. Okay, one both input, this output. Now what we will do, first we will set the bit, means set is 1 and reset is 0. Okay, 1. See, the output will be 1. Okay, input 1 means set is 1, output is 1. Okay, now what we will do, set to 0. At this time also this will be latched. Now we will, to turn off this, we have to make S to 0 and R to 1. At this time the output will go off. Okay. Now, what if we turn on both inputs? 1 1. I don't know, you have studied in your engineering or while you have doing your studies. At that time, the output of when both inputs are 1, the output is toggled. So here the output is 0. Okay. Again we can do this: set 1, reset 0, reset 1, set 0. Okay, both 0. So this is the working of SR flip flop. Okay, now we will work on RS flip flop. Okay, so this is the ladder diagram of RS flip flop. Here the first input is connected to R and the second input is connected to S. Okay, and this one is the output. Here, as per the truth table, let's see how it works. Okay, so here what I have taken, input is 10 for I 1.0 and 1.1. So this is I0. So in this is I 1.0, I 1.1, and this one is the Q 0.2. So when we set this, means this is not set actually. Here the R is first. It means input 1 is reset. It means when we reset this, the output will be off only. When we set this, the output will go on. Okay, now at this condition, when we make it 0, okay, both outputs are 0, both inputs are 0. At this time, the beauty of any flip-flop that it stores the previous state. Okay, in SR also we have seen that, and in RS also. At the first time when the output is on off, that time the if both inputs are 0, then output will be also 0. But if we turn on the output and after that we make both the inputs off, that time the output will remain on only, as it stores previous state of output. Okay, now what we will do here, the twist comes. Now we will turn on both the device, both the inputs. When we turn on means 1 1, the output go 1. Okay, this is not happen in SR, RS. Sorry, SR. In SR, when we turn on both input, the output goes off. But in RS, when we turn on both inputs, the output goes on. This is the difference between two. Okay, now as here you can see, when in SR flip flop, these are the inputs of SR, the last previous state of this Q 0.0 was off. Now when I turn off both inputs, it stores the last state. And in RS flip flop, the last state of output was on. So when I turn off both the inputs, it stores the last state of output, means on. Okay, to turn off this, what I have to do, make reset on and then off. Okay, so where we can use this RS and SR flip flop, where we can use this, so just we have to remember two things. In SR flip flop, when we turn on both inputs, it means when there is emergency or any problem, the outputs goes off. So wherever in any application we want the output should go off, means if there is any motor or any furnace system, heating system, cooling system, anything, that time we should prefer this. It will turn off the output, means there will be no any damage or hazardous condition, to avoid any hazardous condition. And where we can use this RS flip flop, if this output switch will be emergency switch. Okay, so before emergency switch we can use the RS flip flop. Means if there is any problem or both conditions are on, that time the output means emergency switch should go on. Okay, so here you can see a simple difference that PLC, what PLC prefer, PLC prefer left to right, top to bottom rule. So here the our last state is, or last input is reset. That means it goes off when there is condition of 1 1. And in RS the last input is S, means set. So this will go on when both the inputs are 1 1. This is a simple logic. Hope you like this video. So please, if you like this, you can comment, you can share the video and subscribe. Thank you.